Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is SITI SARA AISHAH. My matric ID is CA20046. Today I will present about the software defined networking, also known as SDN. Okay. First, what is SDN? SDN is an architecture designed to make a network becoming more flexible and easier to manage. SDN also centralizes management by abstracting the control plane from the data forwarding function in the discrete networking device. Okay, next I will explain the element of SDN, which are controller, southbound API, northbound APIs. A controller is the core element of SDN architecture that enables centralized management and controls automation and policy enforcement across physical and virtual network environments. Then, southbound API, which relay information between the controller and the individual network devices such as switches, access points, routers, and firewalls. Lastly is northbound APIs that relay information between the controller and the application and policy engines, to which an SDN looks like a single logical network device. Okay. There are some of importance of SDN. First is to increase control with greater speed and flexibility. Instead of manually programming multiple vendor-specific hardware devices, developer can control the flow of traffic over a network simply by programming an open standard software-based controller. Networking administration also have more flexibility in choosing networking equipment since they can choose a single protocol to communicate with any number of hardware devices through a central controller. Next is customizable network infrastructure. With a software-defined network, administrator can configure network services and allocate virtual resources to change the network infrastructure in real time through centralized location. This allows network administrators to optimize the flow of data through the network and prioritize applications that require more availability. Lastly is robust security. A software-defined network delivers visibility into the entire network, providing a more holistic view of security threats. With the proliferation of smart devices that connect to the internet, SDN offers their advantages over traditional networking. Operators can create separate zones for devices that require different levels of security or immediately quarantine compromised devices so that they cannot infect the rest of the network. Okay. Next, how does SDN work? A packet arrives at network switches and rules built into the switch proprietary firmware tell the switch where to forward the packet, and these packet handling rules are sent to the switch from the centralized controller. The switch then queries the controller for guidance as needed, and it provides the controller with information about traffic it handles. All the packets destined for the same host are treated in a similar manner and forwarded along the same pathway by the switch. The virtualization aspect of SDN come into play through a virtual overlay, which is a logically separate network on top of the physical network. In order to segment the network traffic, end-to-end overlay can be implemented. Thus, user can abstract the underlying network as well. This micro-segmentation is especially useful for service providers and operators with multi-tenant cloud environments and cloud services, as they can provision a separate virtual network with specific policies for each tenant. Okay. Next, there are some benefits of SDN. First, which is simplified policy change with SDN. An administrator can change any network switch rule when necessary, prioritizing, deprioritizing, or even blocking specific type of packets with granular level of control and security. This capability is especially helpful in cloud computing multi-tenant architecture, as it enables the administrator to manage traffic loads in a flexible and efficient manner. Essentially, this enables administrators to use less expensive commodity features and have more control over network traffic flow. Next, network management and visibility. A network administrator needs to deal with only one centralized controller to distribute policies to the connected switch. This is opposed to configuring multiple individual devices. This capability is also a security advantage because the controller can monitor traffic and deploy security policies. If the controller deems traffic suspicious, for example, it can reroute or drop the packets, reduce hardware footprint and OpEx. SDN also virtualize hardware and services that were previously carried out by dedicated hardware. This result is in the thought benefit of reduced hardware footprint and lower operational costs. Networking innovation. SDN also contribute to an emergence of software-defined wide area network (SD-WAN) technology. SD-WAN employs the virtual overlay aspect of SDN technology. SD-WAN abstract the organization connectivity link throughout its WAN, creating a virtual network that can use whichever connection to the controller deemed fit to send traffic. Next is cost saving. In the past, the most effective way to ensure network availability was through redundancy, which of course comes with additional equipment and circuit and cost. Because SDN offers the real-time ability to automatically reroute or to stand up new function and route, you can increase your pipe of uptime, which adding new hardware and increasing costs. Lastly is faster scalability. SDN offers automated scaling up and scaling down. This ability combined with additionally visibility it brings gives engineer the operational ability to normalize traffic across the white space and to do it quickly and seamlessly. Okay. Next is SDN is different from traditional network. SDN is software based while traditional networking is hardware based. SDN is more flexible than traditional networking as it allows administrators to control the network, change configuration setting, provision resource, and increase the network capacity all from a centralized user interface without adding more hardware. SDN also offers better security than traditional network. Okay, next is type of SDN. There are four types of SDN, which are Open SDN, SDN by APIs, SDN overlay model, and hybrid SDN. Open SDN uses open protocols to control the virtual and physical devices responsible for routing the data. Packets API SDNs use program interfaces, often called softbound API, to control the flow data of to and from each device. Overlay model SDN creates a virtual network above existing hardware, providing tunnels containing channels to data center. These models then allocate a bandwidth in each channel and assign devices to each channel. Hybrid model SDN combine SDN and traditional networking, allowing the optimal protocol to be assigned for each type of traffic. Hybrid SDN is also often used as a phase-in approach by SDN. Okay. In conclusion, network management continues to evolve as SDN viable option for those that are working to make their business more flexible and adaptable and want to break away from the constraint of traditional network. Data center and their corporate customer alike can benefit from the quick, easily programmable, secure, and transparent architecture of SDN, so they can move at the speed of business. Okay, that's all from me. Thank you.